Okay, so picking up where I left off. Now we're going to take and reflect over the x-axis. So I'm going to uncover this. And now, if you reflect, here, I'm going to get my color going. If we were to reflect 5 pi over 6 over the x-axis, then that would reflect to right here. So if you look at those, you got square root of 3 over 2 and 1/2, square root of 3 over 2 and 1/2. But now what happens is when you're in the third quadrant, every point in the third quadrant is a negative negative because you have to go to the left and down. So now both coordinates are negatives. And then you can reflect, get the green, if you reflect the 135 over the x-axis, that takes you to 225 degrees. And if you look at these points, they look the same. The only difference is both are negative now. And the same thing goes with the blue. So if we take 2 pi over 3 and reflect it over the x-axis, now we're here at 4 pi over 3. The points look the same. The only difference is we have two negatives. And then with the fourth quadrant, again, you have all that same symmetry, but now every point in the fourth quadrant is a positive, comma, a negative, because you'd be going to the right, which is positive, and down, which is negative. And so all that symmetry stuff still applies. But I'll do my color coding here. So if we reflect the blue in the y-axis, that will now go here. If we reflect the green in the y-axis, meaning from the third quadrant to the fourth quadrant would be a reflection in the y-axis. Or I could take first quadrant and reflect it over the x-axis. Okay, and then here's the last one, the red one. So if you look, all the red points look the same. They all have square root of 3 over 2, comma, 1/2. But it's just their signs that change. If you look at all the greens, they're all square root of 2 over 2, square root of 2 over 2. It's just the signs change. And if you look at all of the blues, all the blues have a 1/2 first and a root 3 over 2 second. It's just the sign changes. So it's all symmetry. So again, if you can just remember the first quadrant, all you have to do is reflect and make the sign changes to get the rest. I don't know why there's this little mark right here, but I'll get rid of it. Okay, so now we're going to use the unit circle. Okay, now we're going to use the unit circle to find these exact values. So what that means is you're going to go 2 pi over 3 on the unit circle, and then you're going to figure out what the value of sine is. So remember a few back here. See how it goes cosine, comma, sine? Sine would be the second one. And the angle we need to go to is pi over 3. Okay, pi over 3 is right here. And again, it goes cosine, comma, sine. So if we want sine of pi over 3, it would be square root of 3 over 2. And that's your answer. Okay, for number 2, we're going to go to 2 pi over 3, and we're going to figure out what cosine is. So where's 2 pi over 3? 2 pi over 3 is right here, and we're going to figure out what cosine is. Cosine would be the first one, which is a negative 1/2. Okay, now we're going to go to 5 pi over 4 and figure out what cosine is. 5 pi over 4 is right here. Cosine is the first one, so it'd be negative root 2 over 2. Okay, now this one's a little different. Negative 7 pi over 3. If you look around the unit circle, there's no negative 7 pi over 3. Okay, so let's find a coterminal angle that is. So again, to find a coterminal angle, you add 2 pi or subtract 2 pi however many times you need to. So I'm going to add 2 pi, and I would need a common denominator, so I would multiply by 3, and that would give me negative 7 pi plus 6 pi. That'd be a negative pi over 3. Well, that's still negative, so I could add 2 pi again. So now I would have a negative pi plus 6 pi. That would be 5 pi. 5 pi over 3. That is on the unit circle. So this will be the same thing as sine 5 pi over 3. So we're going to go to 5 pi over 3 and we're going to figure out what sine is. 5 pi over 3 is right here. And sine is the second one. So a negative root 3 over 2. Do you see how negative 7 pi over 3 is the same thing as negative pi over 3 is the same thing as 5 pi over 3? Let's think about that negative pi over 3 for a second. Here is pi over 3, 60 degrees. Here, let me mark it. Okay, here's pi over 3. Negative pi over 3 would go the opposite direction. So this is also, this 5 pi over 3 is the same thing as negative pi over 3. If positive is 60 degrees, negative would be negative 60 degrees. It would land here. Let's see. I don't know why this isn't fitting. Use the unit circle to find the exact value of all 6 trig functions for the given angle. We're going to skip that page. Hang on. This is what I want to get to. Hang on just a second. I want to try to resize the page. Okay, there, that's better. All right. You might be given a point on a circle and you'll be asked to find all 6 trig functions. All you need to do is take that point on the circle and form a triangle with it, and then you'll be able to find all the trig functions. So here's kind of the instructions. Build a triangle. Theta is always next to the origin. The angle that you're going to use is always next to the origin. The right angle should always be on the x-axis, not the y-axis. And the hypotenuse is always positive. So here's an example. I've got my circle. I've got a point on the circle. What I need to do is turn it into a triangle. So you see how I could go like that, and then my right angle would be on the y-axis? That's not what I want. I want the right angle on the x-axis. So that's incorrect. So if I'm going to turn it into a triangle, I'm going to bring this down, and now my right angle is on the x-axis. And theta is supposed to be next to the origin, so theta would be right here. Now, if I want to get to this point right here, I would have to go over and up some amount. Now we could do this a couple different ways. Probably a fairly easy way to do that would be to say, okay, well, I'd have to go over negative 4/5 amount, and I would have to go up 3/5 amount. Okay, now I could find the hypotenuse that way. I could do Pythagorean theorem and find the hypotenuse. And then if I wanted to do sine, sine is opposite over hypotenuse. Well, the other way I could do it is to remember that every single point on the unit circle, or on the circle, it goes cosine, comma, sine. So sine is 3/5. Okay, but if you don't quite believe me, if we did Pythagorean theorem, if we did 3/5 squared plus negative 4/5 squared equals c squared, what would we get for the hypotenuse? Well, these two together, if you type them in your calculator, you get a 1. So the square root of 1 is 1. So this is a 1. So again, if I was going to use the blue stuff, sine is opposite over hypotenuse, that would be 3/5 over 1, which is just 3/5. Or do you see how the second one is sine, 3/5? Cosine, either way you want to do it, you could do adjacent over hypotenuse, that'd be negative 4/5 over 1, or look here, cosine is negative 4/5. Okay, tangent, I'm going to run out of room here. Tangent, if we go back a few slides, back, to here. See how tangent is sine over cosine? That's a good one to remember. Tangent is sine over cosine. Okay, so if I did sine, which is 3/5, over cosine, which is negative 4/5, I could take 3/5 and multiply by the reciprocal, which would be negative 5/4. And the 5's cancel, so I would have a negative 3/4 for tangent. Okay, now the reciprocal functions, we just literally take the reciprocal. So which one was the reciprocal of sine? It was cosecant. So all you do is flip the fraction and say 5/3. Which one was the reciprocal of cosine? Secant. Flip this, we're going to get negative 5/4. And the reciprocal of tangent is cotangent. And flip that, we get negative 4/3. Okay. This is the last example, and then I'm also going to record a video of going over some homework problems from 4.1, those linear speed and angular speed problems. So when you're done watching this, look for the video about going over the homework problems from 4.1. Okay, really quick, let's say this was our problem right here, cosine 5 pi. Well, 5 pi is not on the unit circle, so we would find a coterminal angle with it that is. So I can add or subtract 2 pi however many times I want. If I subtract 2 pi, I get a 3 pi. That's still not on the unit circle. So if I subtract 2 pi again, I get a pi. Well, that is on the unit circle. So cosine of 5 pi is the same thing as cosine of pi. So go to pi. What's the value of cosine? Cosine is the first one, so the value of pi is negative 1. You can always find a coterminal angle if you don't see the angle on the unit circle. Okay, so now go and watch me going over the homework problems from 4.1. Okay, bye.